Namaskar. I am Neha Bahuguna from Army Public School, Shankar Vihar. Today in this session, we are going to discuss planning to teach mathematics using multiple intelligences and Bloom's taxonomy. Envisage entering a classroom not as a teacher but as an explorer with a mission to guide the students through this intricate maze called mathematics, imparting the skills and techniques necessary to navigate its complexities with confidence and become adept 21st century problem solvers. Like a captain charting a course, we need meticulously plan our lessons using three vital tools as instruments to navigate this shared voyage. They are SMART goal setting, Bloom's taxonomy, and Gardner's theory of multiple intelligences. Effective lesson planning offers a multitude of advantages, making it an essential tool for successful learning journeys. Here are some of them. First is organization and focus. Lesson plans provide a clear roadmap for the lesson, ensuring that all key points are covered and the time is used efficiently. This helps teachers stay organized and focused, preventing them from going off track or forgetting important details. Second is preparation and confidence. Planning allows teachers to gather necessary materials, anticipate potential challenges, and prepare engaging activities in advance. This leads to increased confidence and preparedness in the classroom, resulting in more effective delivery. Third is reflection and improvement. By revisiting and reflecting on lesson plans after teaching, teachers can identify areas for improvement and adjust their strategies for future classes. This cycle of planning, teaching, and reflecting leads to continuous development and better teaching practices. Fourth is adaptability and differentiation. Lesson plans can be easily adapted to accommodate the learning styles and needs of different students. Teachers can incorporate various activities, assessments, and differentiation strategies to ensure that all students are challenged and engaged. Fifth is accountability and documentation. Well-documented lesson plans serve as a record of what was taught and how, providing transparency and accountability. They can also be useful for collaboration with colleagues, substitute teachers, or administrators. For students as well, effective lesson planning provides a clarity of purpose, ensuring active engagement and thereby contributing to improved learning outcomes. Preparing the toolkit. Elements of a mathematics lesson plan. A successful lesson plan addresses and integrates three key components. First is learning objectives and learning outcomes. Second, the learning activities. And third, the assessment to check for student understanding. SMART goal setting. Setting a clear path forward. I quote, "If you're not sure where you are going, you are liable to end up somewhere else." Learning objectives attempt to state what students will achieve by the end of a particular lesson, module, or course. SMART objectives make this more explicit by ensuring that the learning objectives are specific, measurable, achievable, relevant, and time-bound. Every SMART learning objective that we plan must be translated as a learning outcome. Consider SMART goals to be robust signposts pointing to major destinations on your mathematical journey. Let us see what S stands for in SMART. Each learning objective and outcome we plan should be specific. S stands for specific. Rather than striving for a broad understanding of fractions, for example, it is necessary to be specific, such as students will be able to subtract fractions with unlike denominators using a common denominator. M in SMART refers to measurable. How will we know when we arrive at our destination? Setting goals and planning for assessments in the form of exit tickets, quizzes, or problem-solving activities help track student progress, making the objective measurable. A in SMART refers to attainable. It is important to set challenging yet achievable goals considering students' current understanding and their learning pace. R in SMART refers to relevant. It is of paramount importance that we connect learning objectives to real-life contexts or other subjects and areas. Showing students why fractions matter beyond worksheets, perhaps by encouraging them to calculate the pizza slices or plan a budget, can help make learning concrete and meaningful. T in SMART is time-bound. This element refers to having a specific time frame for achieving your goal. Setting a deadline creates a sense of urgency and helps you stay on track. It also allows you to measure your progress and determine if you are moving in the right direction. Climbing Bloom's mountain, reaching new heights of thinking. Bloom's taxonomy isn't just a fancy chart. It's a roadmap to developing higher order thinking skills. It is a framework for planning and measuring the level of cognitive complexity required by a particular learning objective. The taxonomy is divided into 6 levels, each of which corresponds to a different type of thinking. These levels are remembering, understanding, applying, analyzing, evaluating, and creating. Let us consider writing a lesson objective to be a mountain climb. Then Bloom's taxonomy gives us 3 steps. Lower steps. Begin with activities like identifying shapes or recalling the formulae. These provide a firm foundation for developing more complicated reasoning, such as recognizing mathematical structures and discriminating between concepts. This is the remembering and understanding level of Bloom's taxonomy. Middle ground. It is important to challenge the students to use their knowledge to solve problems, explain and present their thinking and ideas to their peers, or compare alternative solutions to determine the best suitable solution or argument in a situation. This addresses the applying and analyzing levels of the taxonomy. This is where critical thinking begins to flourish. Reaching the summit. As a final step, it is imperative that our lesson encourages the students to critically analyze different solutions to a problem, justify, evaluate the reasoning, and even construct their own mathematical models to test or explain their logic, their understanding, and their solution. This relates to evaluating and creating levels in Bloom's taxonomy. This is when independent thinking and inventiveness really flourishes. Using Bloom's taxonomy to develop lesson objectives allows the teachers to ensure that they are effectively challenging the learners while also promoting higher order thinking skills. that are crucial 21st century educational goals. Considering and incorporating Bloom's taxonomy can greatly assist in developing deeper knowledge and a better memory of the content being taught. Planning the specific learning activities. It is important that the learning activities be aligned to the lesson's learning objectives. There are certain questions we should consider. What will I do to explain this topic? What will I do to illustrate the topic in a different way? How can I engage the students in the topic? What are some relevant real-life examples, analogies, or situations that can help students understand the topic? What will students need to do to help them understand this topic better? Criteria for framing good learning activities. Designing good learning activities involves more than just knowing information and throwing it at the students and hoping it sticks. It is about crafting engaging experiences that can spark their curiosity, promote deeper understanding, and leave them with lasting knowledge and skills. To achieve this, there are several key criteria to consider when framing the learning activities. They must be in alignment with the curriculum and be age appropriate. They must spark critical thinking, analysis, and creativity. They ought to be applicable to relevant real-world scenarios and aim to encourage students to reflect on their learning process. We need to remember, good learning activities are not one size fits all. It is important to consider the specific learning objectives, your students' needs and interests, and the available resources when designing your activities. By incorporating these criteria and focusing on a positive and engaging learning environment, we can create activities that foster a love for learning and build lasting knowledge and skills in our students. Keeping in mind the diverse learners in our classrooms, we can employ Dr. Howard Gardner's theory of multiple intelligences to frame effective learning activities. Engaging all minds using Gardner's multiple intelligences. Students' learning styles and intelligences vary, making classrooms rich in diversity. Understanding how different students learn the best allows us to design lessons that appeal to all minds and help them reach their full mathematical potential. Let us look at the 9 intelligences as suggested by Professor Howard Gardner and explore some of the ways to ignite mathematical engagement using them in the class. First, linguistic intelligence. Activities may include mathematical storytelling, problem-solving debates, and writing rap songs about theorems, laws, or mathematical relationships. The tools suitable for addressing linguistic learners include word puzzles, mathematical crosswords, vocabulary games, and open-ended math conversation questions. Second, logical mathematical intelligence. Activities to address logical mathematical intelligence amongst learners may include creating logic puzzles, code-breaking challenges, math escape rooms, and the opportunity for individual problem solving. Third, the visual spatial intelligence. Activities include creating geometric art, making origami structures, and understanding the graphs and the diagrams. Students can be encouraged to use interactive simulations, graphic organizers, and physical models to represent mathematical relationships. Fourth, bodily kinesthetic intelligence. Math games, simulations of physical processes, and role-playing scenarios can all help students get active. Students can be encouraged to use manipulatives, body movements to depict mathematical concepts and operations, and kinesthetic exercises to reinforce mathematical ideas. Fifth, musical intelligence. Students can be encouraged to compose rhythmic problems, analyze musical patterns, and write math-related songs or jingles. They can be encouraged to use music to represent data sets, look for patterns in equations, and create a stimulating learning environment. Sixth, interpersonal intelligence. Activities include collaborative problem solving, peer tutoring, and group presentations of mathematical concepts. Tools for promoting communication and collaboration among students include group projects, debates, and role-playing games. Seventh, intrapersonal intelligence. Activities include creating autonomous learning activities, self-reflection exercises, and opportunities for individual investigation of mathematical concepts. To accommodate the varied learning styles, use tailored learning plans, writing prompts, and student choice opportunities. Eighth, naturalist intelligence. Activities include applying arithmetic and mathematical ideas to real-world occurrences, exploring the natural patterns, and investigating environmental issues using mathematical models. Using outdoor learning, models of natural processes, and real-world data sets to make mathematics more understandable and applicable. Ninth, existential intelligence. It involves delving into the deeper meaning and purpose of mathematics, connecting it to broader questions about human existence and the universe. This intelligence can be incorporated in our lesson by discussing the development of mathematical concepts and notations throughout history, considering the impact of mathematicians and their discoveries on the society and culture, and discussing the ethical implications of using mathematical algorithms in areas like artificial intelligence and decision making. Best practices for learning activities. To get the most out of our learning activities, it is essential to follow a few guidelines. Arrange the activities from simple to complex. Ensure that conceptualization happens first, with comprehension following it and culminating in the application level of learning. Organize the activities in such a way that they elicit the desired reaction, the response, and provide maximum reinforcement. Ensure that the activities are directly linked to the desired goals, the learning objectives, and are arranged according to the facilities available in the immediate environment of the school. By thoughtfully considering these criteria and applying Bloom's taxonomy as a framework, you can design effective learning activities that promote deeper understanding and lasting knowledge and development of valuable skills in your students. Beyond the tools, the heart of effective lesson planning. Remember, these tools are just the beginning. Effective lesson planning is a dynamic process that values flexibility and reflection. Prepare to alter your plans to meet the requirements of your students and adjust the activities as the lesson progresses. Most importantly, never underestimate the power of curiosity and amazement. Allow your classroom to be a place where curiosity is encouraged, mistakes are accepted as learning opportunities, and the thrill of discovery motivates the adventure through the mathematical maze. With a well-equipped toolkit and a passionate heart, you can help your pupils not only navigate the math maze, but also appreciate the beauty and power of mathematical reasoning. So, dear explorer, are you ready to embark on this adventure? Remember, the greatest discoveries often lie beyond the familiar. With the right tools and a spirit of curiosity in your heart, your math lessons can become journeys of endless fascination and intellectual growth for both you and your students. Namaskar.